Alright, this is the final video I'm going to make for the unit on linear relations. And in this one we're going over interpolating and extrapolating data. And what this is really all about is being able to read a graph. Let me just explain the difference between interpolation and extrapolation. So when you're looking at a graph, let's say this is the amount of information that you have from here to here. To interpolate data is to analyze within the data set that you're given. So anything along there, for example, if you were looking for that point, that would be interpolation because it's inside or within the data given to you. Extrapolation, as you might guess, would be finding data that's outside of what's given to you. That would mean actually having to extend the information that you know. And so if you were looking, for example, this point up here, that would be extrapolation because that's outside of the data that was given to you. So those are the two differences. Let's go ahead and look at a couple examples. Okay, on the left here, we're looking at the cost of a cell phone by the number of months. So we can see as the number of months increase of owning a cell phone, the price also increases. Now for an example question you might get is, after 9 months, how much are you paying? So what's the cost? And you can see in order to solve that, we need to find the point along this graph, along this line here, that has occurs at the 9-month mark. And you can see we've actually already drawn in the red line here. At this point, we can see that that matches the 9-month period. And then all we need to do is find out the cost, which is our y-axis over here. And we can see that it's a bit more than 400. And usually in questions like this, you do need to give an estimate as your answer. I know that if this is 400 and this is 500, halfway between that would be 450. And it looks like it's about halfway between 400 and 450, which would be 425. So after 9 months, it would be $425. One more example is you could be asked maybe how long have you owned the phone if you've paid let's say $350. Okay, so in that case, we're being given the y value, the cost at $350. So I'm going to go find the spot along the y-axis that's matches $350, and that's right here. And then all I need to go is go across until I reach the grid or the graph given to us. And then we need to figure out what is the number of months at that point. And if we head down, we'll see it's just over 7 months. So if we're giving an estimate, I would say 7 months because it's pretty close to that. All right, let's try another example. Let's go over here. Oh, by the way, in that last example, both of those questions were examples of interpolation because what we were trying to solve was inside the data set given to us. All right, this is also going to be another example of interpolation. So this looks like gasoline usage, and we're comparing the gallons in the tank of a vehicle and the miles driven. So as you can see, the more miles someone drives, the less gasoline is in their tank. All right, a couple questions we can try. First one is, how many miles have you driven if there's 9 gallons left in the tank? So the information we're given is 9 gallons, and that's along our y-axis. So I'm going to find 9 gallons, which is right here. And I'm going to draw a line and go on across until I reach the graph, which is there. And then all we need to do is move down to read how many miles have been driven at that point. And it looks like it's actually exactly 150. So that one would be 150 miles. Now for our other one, the next question is how many gallons are left in the tank after 50 miles? So in this case, we've been given our X value, the amount of miles driven, and that's at 50, so that's right here. So what I'm going to do this time is draw a line up until I reach the graph right there. So that's our point, which has a Y value of 13. So the answer would be 13 gallons would be left in our tank of gas. Okay, just one more quick example, because again, this was interpolation. I haven't shown you what extrapolation looks like yet. So we need to do one more example. Let's head down here for this one. On the left here, we have a graph that's titled Heated Water Temperature Change. So we can see that the temperature of the water is increasing as the time increases that it's being heated. And we can see that after, for example, after 50 minutes, the temperature of the water is 70 degrees Celsius. Now the question we're given is, what is the temperature of the water after 80 minutes? Now if we follow the same strategies before, we're given 80 minutes, which is our X value, and we can see it right here. So what I would do is draw a line straight up until I reach the graph. The problem, as you can see, is that the graph doesn't go that far. So in an example like this, we need to extrapolate the data, and what that means is to draw it longer, assuming this pattern continues. And obviously, to be the most accurate, we would want to use a ruler. Luckily for me, I can just draw this little straight line guy here, and I'm going to extend this line, and boom! Okay, so we can see that if this pattern were to continue, it looks like at about 80 minutes that the temperature of the water would be 100 degrees Celsius. I can see that because that go across there. So that's an example of extrapolation. All it means is that you have to extend the data that's given to you, or the pattern. All right, that's it for this unit.